This question was asked in 2026 Class 12 CBSE board exam. This is from the chapter Relations and Functions. Take a look at the question. A school wants the students of class 12 to do a project. So we are going to skip this story part and get to the main part where information is given. Seven students of 80 out of 80 are selected for the project and they are categorized into two sets. Set A is set of girls G1, G2, G3 and G4. Set B is set of boy students B1, B2, B3. Based on the above information, answer the following questions. How many relations are possible from set A to set B? So if A contains m number of elements and B contains n number of elements, we know that the number of possible relations is 2 power mn. So that should be equal to 2 power, in this case it is 4 and 3. So it should be 2 power 4 into 3, which is equal to 2 power 12. So the answer should be 4096. On to the next question. Let R be a relation from A to B such that R is given as G1, B1, G2, B2 and so on. So what I'm going to do is I'm going to quickly make this as a function kind of arrangement. So G1, G2, G3, G4. So this is set A for second subdivision. Set A and set B, I'm writing it down. So B1, B2, B3. Now G1, B1, arrow from G1 to B1, G2, B2, and then G3, B2, and then G4, B3. Now, is R an injective function? The other meaning of injective is it is an onto, one-to-one function, not onto. Is R an one-to-one function? Now, take a look at G2, B2, G3, B2. So, the meaning of one-to-one is that it should not receive inputs from more than one input, correct? More than one element of the domain set. But B2 has inputs from G2. So the pre-image of B2 is both G2 as well as G3. So which means it is not one-to-one. It has to be many-to-one function. So the answer to this question is it is not. So justify your answer. This should be the justification. Just draw the arrow diagram and justify that B2 receives input from G2 as well as G3. On to the next question. Third A. Let R be a relation from A to A such that x comma y, where x and y they belong to A. So parent set is what? A, which is the set of all girls, correct? Now A is the set of girls which is G1, G2, G3 and G4. And here they are students from the same colony in the city. Now, I'm wondering if they are meaning for this question. Here, are they meaning it for this question that all the girls are from the same colony in the city, or is it a generic set A? So, what I'm going to do is, I'm going to write this as, so let's say this is reflexive. They're asking us to prove whether it's an, verify whether it's a equivalence relation. So, reflexive relation, right? For all A, the element that belongs to parent set A, the relation is defined by R is a set of all A comma A, or we can just write it as A comma A belongs to R. A comma A belongs to R if and only if A and A belong to the same city. Definitely A and A will belong to the same city. A is going to be in the same city as A himself or herself, correct? So definitely it's a reflexive relation. That's it. So you have to compare. For reflexive, you have to check from the parent set and not from the relation set. For symmetric relation for all a comma b that belong to the relation set, it already means that a and b are from the same city. Is it same city or same colony? I think it should be the same colony. Yeah. So a and b belong to the same colony. Now b comma a will also belong to the same R, right? So B and A will belong to the same relation. So B and A, definitely if A and B belong to the same colony, B and A are also going to belong to the same colony. B and A cannot be in different colonies, right? It's literally A and B and A, both are same. So it has to be symmetric. Hence it is symmetric relation because for every A comma B that belongs to the relation set R, B comma A also belongs to the relation set R. On to the next question. So transitive for all, the condition is for all a comma b belongs to R and b comma c that belongs to R. If a comma b, I mean a comma c belongs to the relation set R, then we can call that relation to be transitive. So here if a and b belong to R, so these two, if it is true, a and b, they belong to the same colony, right? B and C also belong to the same colony, which means B is sharing the same colony as A, B is sharing the same colony as C, which means all three A, B, C, they belong to the same colony. Going by this logic, we can also say that A and C, they belong to the same colony. That is why we can say that the relation is also transitive. The relation has satisfied reflexive, it has satisfied symmetric, it has satisfied transitive, so it is an equivalence relation. Okay, on to the next question. Verify if f defined from B to A is bijective. For this question, what is set B? Set B is a set of all boys. So B1, B2, B3. And G is a set of all girls. G1, G2, G3. Mind you, G4, which means there are more elements in G set than in B set. I think this should be A. B to A. The function is defined from B to A. We are going to check whether the function is bijective or not. It does not prove that question. It is verify whether f is bijective. Verify if it is bijective. The previous question, it was an equivalence relation, but in this question, it's verify. So we are going to see whether it's bijective or not. Clearly, if you make arrow diagrams from B1, G1, just do it randomly also, it won't make a difference. B1, G2, make it something like B2, G3 and B3, G4. Clearly, one of them is going to be left out. One of them is not going to receive an arrow from one of the domain elements. So this happens now. This happens because there is one element extra in the codomain, which is set A, right? So you will write the reason as since the number of codomain elements is more than the number of domain elements, we can say that the codomain is not definitely equal to range, because the range is going to be one short of codomain, right? So codomain and range not equal, this results in the the relation being not onto. Since it is not onto, we can say that it is also not bijective. I hope you would have understood this case study. If you have any more questions to be discussed, let me know in the comment section below.